So today we are going to be working on a lesson on linear functions and standard form. So we're going to determine if an equation is a linear. We're going to be able to write a linear function in standard form. We're going to graph a linear function using its x-intercept and y-intercept. And we're going to also use a linear equation to solve an application problem. So let's state whether each equation or function is linear. We're going to write yes or no, and if it's no, we're going to explain our reasoning. So looking here at number 1, here it says y equals 3x. So as you're trying to figure out if something is linear or not, you want to see if it can be put in the form of y equals mx plus b. Or if I use function notation, I can substitute f of x in here for y and see, can I write it in mx plus b form? So our first example there is y equals 3x plus, it's just y equals 3x. So if I were to add, for instance, a plus 0 here, then it's going to look exactly like this, y equals mx plus b, or f of x equals mx plus b. Because you can see your slope here is 3, and your y-intercept here would be b, which would be 0. So yes, that is a linear function. What about this next one here, y equals negative 2 plus 5x? Well, it doesn't look exactly like y equals mx plus b, but I could rearrange this and say 5x minus 2. So now I could definitely say, oh yeah, my slope here is 5 and my y-intercept is negative 2, and I just have an x to the first in there. So yes, this is also linear. What about this next one, 2x plus y there equals 10? Well, the x is over there by the y, so let's move it on the other side. And so then we get y equals a negative 2x plus 10. So now it's in that form of y equals mx plus b form. So this is definitely yes. It is linear. What about number 4? Now number 4 there has an x squared in it. So it doesn't have an x to the first. So we're always looking, one thing we're looking for is, can we put it in y equals mx plus b form there? And is it x to the first power? Well, this one here is x to the second power here. So we're going to say, no, this is not linear. It's actually a quadratic. And so you could say because it's a quadratic, or you could say because of x squared, or like I said, because it's a quadratic is not linear. It's not a linear function, it's a quadratic function. Or it doesn't make a line, it makes a parabola. So you could also put these into your graphing calculators once they're y equals or f of x equals, and see it that way as well. So let's look there at number 5. Number 5 has x down here in the denominator. I mean, we could bring everything over on one side. We could go ahead and add 3 over x, so we get 3 over x plus 15 over here. But x is still down there in the denominator. Our x in the other problems up there, like number 3 there, we got y equals negative 2x plus 10. There isn't an x down the denominator. You can't have an x in the denominator. So no, because x is in the denominator. Or if you want to name what kind of function this would be a rational function. All right, so then number 6 there. Nothing wrong with a 1/3 times x, because it's not 1 over 3x, it's 1/3 times x. So I'm going to bring this 8 over here by the 1/3 x. So I get 1/3 x minus 8 equals y, which is the same thing as y equals 1/3 x minus 8. So again, our slope there is 1/3. It's a negative 8 there would be my b, so it's in that y equals mx plus b form. And you have an x to the first there. So that is definitely a yes, this is a linear function. What about number 7 there, g of x equals 8? So this is the same thing as I can replace that g of x or whatever kind of a function notation they have. If you like to put a y in there so you can put it in y equals mx plus b form, go ahead and do that. So it's kind of looking like that, but I don't have an x in there. So could I put an x in there? Yeah, I could put like a 0x in there because 0 times x is a 0, and 0 plus 8 there is going to give you 8. So is that in y equals mx plus b form? Yeah. So y equals 0x plus 8. 0 would be my slope, and b there would be my y-intercept there. So definitely, yes, this is a linear function. And it makes a nice horizontal line with that one there. What about number 8? Well, you've got a square root in here. So it's not going to be a linear, it's going to be a square root function. The way that you write this one out here, if you were to do it by the powers here, this is x to the 1/2 plus 3. So you don't have that x to the first there either. It's x to the 1/2. And so most people will say no because of the square root of x, or they might say no because, and they'll say, another way of being able to say this is a square root function, if you'd like to say that. So, or you could say x to the 1/2. It's not x to the first, it's x to the 1/2 power. So however you want to explain that. All right. So there are different ways to write linear equations there. One way we have is we have the form of y equals mx plus b. That is your slope-intercept form, which most of you are very familiar with. There's another form that we're going to be looking at here today, and this is called standard form. And so in standard form, the equation there looks, you've got your x and your y there on the same side of the equation, and then you've got a constant on the other side of the equation. So you've got ax plus by equals c there form. And then we have some conditions down here for it to be in standard form. Your b and your c have to be positive or negative whole numbers. All right? And then the other condition here is that a has to be a positive whole number. So let's come down here and let's, first of all, you want to move the x and the y on the same side. So the first thing you do is move terms, so x and y on the same side. Of the equal sign. So let's do that. So I'm going to subtract x, so I get negative x plus y there equals 0. So once I have everything on one side, I'm going to come back up here and look. Are my b and c there positive or negative whole numbers? Now notice b is what's in front of the y. So what's in front of the y here is a nice 1. And then my c value is over here, is that constant, which is 0. Is that a positive or negative whole numbers? Yeah. 1 and 0 there are positive or negative whole numbers. All right, and then the second condition here, it says here that your a value, which is what's in front of x here, which is a negative 1 here, is that value there a positive whole number? No, it's negative. So I'm going to have to multiply this whole equation through by negative 1. So negative 1 times negative 1 there is a positive. Negative 1 times a 1y there is a minus y. And negative 1 times 0 there is 0. So this is what we're looking for. X minus y there equals 0. Number 10. The first thing we're going to do is we're going to move the terms so x and y are on the same side of the equals. So I'm going to subtract 5x. And I get negative 5x plus y equals 1. So again, go through the steps here. Are b and c positive or negative whole numbers? Here's my b value. Here's my c value here. Are those positive or negative whole numbers? Yes. And then the next part here says that a there, which is what's in front of the x there, is that there a positive whole number? No, that's not a positive whole number. Well, then we're going to have to multiply this whole equation through by -1. So then we get 5x minus y equals a -1. I have to multiply every single term in there by -1. So now it's going to meet those conditions up there. And then I'm going to say check conditions for B and C and A. And then if it doesn't work, you got to make sure you change it so it meets those conditions. All right. So we wrote the equation in standard form. And then I skipped the easy one. It says what is A and what is B and what is C. So let's do that. A is what's in front of X. So A there is 1. B is what's in front of Y, which is a -1. And what's C is 0. So this is the second part of the equation that we had, second part of the question that we had to work through. So what about this? The next one, what's A, what's B, and what's C? A there is what's in front of X, which is 5. B is what's in front of Y there, which is a -1. And C is a constant on the other side there, which is a -1. So we got standard form, and then we have identified the pieces there. All right, we have got a few other ones here to work through. So this next one here, I'm going to move my X and Y so they're on the same side. So I'm going to bring my 7Y over here. I get 2X plus 7Y equals 4. So there it is in that AX plus BY equals C form. But now we have to make sure we met the conditions here. What do the conditions there say? That A and B, or B and C there has to be positive negative whole numbers. So 7 is positive 7, and 4 there is a positive 4. So that meets that condition. What about A? A has to be positive. Is A positive and it's a whole number? Yes. So there we have it. So then we just have to identify A, B, and C. So let's do that. My A here is 2, my B is 7, and my constant there is 4. So C there is 4. Now number 12 there has fractions in it. So right away, those are not whole numbers. So what I do here is I go through here. Actually, let's do what we did first here. Let's move our X's and our Y terms on the same side here first. So let's do that first just to make it easier for us to look at it. All right, so we move the 2/3 Y over by the 3/4 X. So now that we have it over there, the only problem is our A and our B there are fractions. We can't have fractions. So what you want to do is when you look down the denominator down here, and the denominator down here is 4, and the denominator over here is 3. So what's the common denominator between 4 and 3? Or you could just multiply them together and you get 12. So you could say 12 is your common denominator. So you're going to multiply every single term in here by 12 to get rid of that fraction there. So then 12 times 3 is 36, divided by 4 there is 9. 12 times 2 there is 24, divided by 3 there is 8. And -2 times 12 there is -24. All right, so now check the conditions because now it's in AX plus BY equals C form. A here has to be a positive whole number, and it is. Are B and C positive and negative whole numbers? Yes, this is a positive one, this is a negative one. So A here is 9, B is 8, and C is a -24. So we needed both of those. We need in standard form, and then we got to identify the pieces. So our next one here is 5y there equals 5y minus 9 there equals 0. So let's bring our x and y terms on the same side. Well, there isn't an x term in there, so I'm just going to bring my constant over on the other side here, and I get 5y there equals 9. If you want to put the x term in there, you can. You're just going to do 0 in front of the x and just do 0x plus 5y equals 9. If that's helpful for you, just go ahead and put that in there. So then you got to identify a, b, and c. A is what's in front of x, which is 0. B is what's in front of y, which is 5. And c there is 9. And notice they're all positive, negative whole numbers, so I didn't have to change anything except bring the constant over the other side. Number 14 here, I'm seeing that I have an x term over here on the right, and I've got a y and a constant term there on the left. So I think I'm just going to bring the y term over on the other side. That way I only have to move one term. And I might even rewrite this in the right order because I like my x here, and then my y, and then my constant. So if you notice, we've got 8/5 x plus 6y equals 14. That first one is a fraction. We can't have a fraction in here. So in our entire equation there, so we have to get rid of that fraction. So what's the denominator down here? It's a 5. So we're going to multiply every single term in here by 5. I'm going to erase this and rewrite it. All right, so I'm going to multiply this term by 5, this term by 5, this term by 5. So 5 times 8 is 40, divided by 5 there is 8x. 5 times 6y there is 30y. And 5 times 14 there is 70. So now I identify my pieces there, and I can look at what's in front of the x and from the y and what's my constant. They're all positive whole numbers there. So a there is 8, b there is 30, and c there is 70. So we didn't have to multiply it by anything to change that except that 5 to get rid of the fraction. Because our leading term there was nice and positive already. All right. So now we're on to the x and y intercepts. So it says to go ahead and find the x and y intercept of the graph of each equation and then graph it out. So to find your x and y intercept here, the easiest way here is say let x equal 0, and then we're going to let y equal 0 in the equation. So in the first equation there, I can just substitute x in there. I can sub 0 in for x and solve for y. So 0 minus 6 there is just a negative 6. So my y-intercept there is negative 6. And then I can go ahead and find my x-intercept here. So I can put 0 in for y and solve this for x. So I can go ahead and add 6 to both sides, divide by 3, and we get x equals 2. So my ordered pair here is 2, 0. So I'm going to plot 2, 0 on here. So that's my x-intercept. And then I've got my y-intercept. That's 0, negative 6. And I need to move this just a little bit. There we go. So then once I have those, I can simply connect them. Now, do you have to graph that way? No. I'll also show you how to graph using y equals mx plus b, but for now, I found the x and the y-intercept, so you might as well just go ahead and graph that way. If you become more comfortable after tomorrow's lessons and you just always want to graph it with the y-intercept and the slope, we can totally do that. But we're supposed to also find the x and y-intercept, so we're just identifying those. So this one here is my y-intercept when we do this, and this one here is my x-intercept. Because you'll have to identify those when you have to do a quiz. You don't have to graph using those, but you can definitely find those. So let's do this again. So let's say let x equal 0 here, and let's find our y-intercept. And then let's let y equal 0, and let's find our x-intercept. So putting 0 in there for x, we get y equals negative 2 times 0, which gives us y equals 0. So it's 0, 0. Let y equal 0 in this case. 0 equals negative 2x. Divide by negative 2, and x there is 0. So both my x-intercept and my y-intercept there is 0, 0. That didn't really help us to graph this out because they're both the same there. So it's up to you how you like to do this. Now some people will come up here and use their slope to graph this out. So they'll come down 2 and then over 1, come down 2 and over 1. It's probably the easiest way to do that because that's your slope, whatever's next to your x there. So my slope here is negative 2 over 1. So I could find another ordered pair by doing that because the x and the y-intercept end up being the same value. But they wanted us to find the x-intercept and the y-intercept, and it ended up being 0, 0, so that's both of those. Both the x-intercept and the y-intercept are the same, and they're same point. All right, so this next one here, again, let x equal 0, let y equal 0, and let's find those. So I'm going to put 0 in for x, solve for y, and I get y equals 5. So this is my y-intercept, and it is 0, 5. I'm going to find my x-intercept, so I get x plus 0 equals 5. X plus 0 there is just x, so I get 5 for my x-intercept. So that's 5, 0. And then I can simply connect my points. So just giving you some tools on how to graph out some linear equations here. So now we've got some constants there, or coefficients there, of x and y besides 1s. So let's do the same thing. Let x equal 0. Let y equal 0. I'm going to put 0 in for x. So then 2 times 0 is just 0, so I just get 5y equals 10. Divide by 5, and y there is 2. So my ordered pair here is 0, 2, and that's my y-intercept. What about my x-intercept? I'm going to go ahead and plug in 0 for y. So what happens? This goes away, divide by 2, and x there is 5. So what's my ordered pair? 5, 0. So let's plot that. 0, 2, 5, 0. Connect my points, and there we have it. So giving you some tools on how to graph a linear function. All right, so our next one here has to do with an application problem of linear functions. We've got the equation of y equals 5,280x gives the distance in feet corresponding to a distance x in miles. What is the distance in feet from Farmington High School to Dakota County Library in Farmington if the distance in miles is 3.52? So the equation here is y equals 5,280x. X is in miles. They're telling you that the miles is 3.52, and we want to find the feet. So what do we have to do? We have to take 3.52 and plug it in here for x, and then y will be what's in feet. So if I plug that, take 5,280 times 3.52, I get 18,585.6 feet. And then our last problem here, you order a hamburger which costs $12 in a restaurant and read books there the whole afternoon. You drink several cups of coffee at $4.50 each, and the cost C in dollars can be represented by the linear function C of x equals 12 plus 4.5x, where x is the number of cups of coffee drank. What is the total amount spent at the restaurant after drinking 4 cups of coffee? So I'm going to go to my equation. It's right here. So C of x equals 12 plus 4.5x. It says that x is the number of coffees drank, and we drank 4 cups of coffee, so we're going to take 4, and we're going to plug it in there for x. 12 plus 4.5 times 4. So when I do that, I end up there getting C equals $30. So now what happens if you drank 6 cups of coffee? Well, let's do that again. So C of x equals 12 plus 4.5 times x. We're going to take that 6 and we're going to plug it in there for x. So we get 12 plus 4.5 times 6. And when I did that, I got $39. So it's just substituting some values into the equations given when it's got a linear function because it's x to the first power. So you're working on the 1.3 worksheet now.